Welcome to this ME1000 video. We are working on modeling the spam-powered car, and we are trying to solve in this video for A sub f, the acceleration of the food or the spam. In class we derived the 8 equations that are here on the side. As you recall, we had 8 unknowns, and so we needed 8 equations. And so we're going to use these 8 equations to, again, solve for A sub f in terms of the design parameters that we know. So we're starting with equation 1. This is equation 1 here. And it has an unknown in it, t, that we need to get rid of. And so we're going to use equation 3 to substitute in for the t. So we will have AF is equal to, instead of t, we're going to have tau sub I divided by r sub s times 1 over mf from the original equation minus g. Now the unknown in our equation is tau sub I, so we can use equation 6 to substitute something in for tau sub I. So we'll use 6. And now we'll have A sub f is equal to 1 over r sub s, 1 over m sub f. And plugging in for tau sub I, we'll put in r sub g tau sub f, and then our minus g. Now we have tau sub f as an unknown, so we can use equation 4 to substitute something in for tau sub f. So A sub f is equal to 1 over r sub s, 1 over m sub f, r sub g, and substituting in for tau sub f, we put in fp rw, and then again our minus g. Now the unknown in our equation is fp, so we will use equation 2 to substitute something in for f sub p. So AF is equal to, I'll move the RW over here so my R's are together, RW over RS times 1 over MF times RG, and then substituting in for FP is M total times AC plus FRR, the rolling resistance force, and minus G. And the unknown in this equation is AC, and so we can use equation 7 to plug something in for AC. Okay, here's that same equation, and again we're going to use equation 7 to plug something in for AC. So AF is equal to 1 over MF, RW over RS, capital R sub G, total, plugging in for AC from equation 7, we're going to have RW alpha W plus FRR minus G. Now we've introduced alpha W as an unknown. That's the angular acceleration of the wheel, and we can use equation 5 to substitute something in for that. So we're going to use 5. So AF is equal to 1 over MF, RW over RS, capital R sub G, total, RW, plugging in for alpha W, we'll get an RG alpha S plus FRR minus G. Now we have an alpha S in our equation. We can get rid of that using equation 8, so use 8. AF is equal to 1 over MF, RW over RS, RG, total, RW, capital R sub G, and alpha s is minus AF over RS plus FRR parentheses minus G. And now we know all of the things in this equation except for AF, and we have two AFs. There's one over here on the left, and now we've introduced one over here on the right. And so we're going to need to get those terms together on the left so that we can solve for AF. Here's that same equation after I've gathered some terms and tidied things up a little bit. Like I said, we have two AFs in our equation and we need to get those together, so I'm going to move this whole term over to the other side, and we will have AF times 1 from that AF plus M tot over MF RW over RS squared RG squared, and that of course was from this term, and that is equal to 1 over MF RW over RS capital R sub G FRR minus G. And now to solve for A sub F, I just need to divide by this grouping. So AF is equal to 1 over MF RW over RS capital R sub G FRR minus G, all divided by 1 plus M total over MF RW over RS squared RG squared. And so here now we have an equation for A sub F. In order to determine the distance that the car travels, we need to know AC, the acceleration of the car, in addition to AF, the acceleration of the food. And so to find an equation for AC in terms of things that we know, we can start with equation 7. So this is equation 7 for AC. AC is equal to RW alpha W. Alpha W is an unknown, so we need to plug something in for that. So we can use equation 5. And we will now have AC is equal to RW times capital R sub G, the gear ratio, times alpha S. Alpha S is an unknown. We can use equation 8 to get rid of alpha S. So AC is equal to RW, capital R sub G. Plugging in for alpha S, we'll put in minus AF over R sub S. And we can simplify that a little bit. RW over RS times RG times A sub F, and we need to get a minus sign in here. So A sub C is equal to this, and for A sub F we can simply plug in our previous equation. And now knowing these two accelerations, AC and AF, we are ready to do the explicit finite difference technique to determine the distance traveled by the car.